I might be a little more out of breath than normal. But I'm super excited to be here and talk to you about an area and a topic that's really near and dear to my heart. I've been talking about this for ages, and I feel like it's finally coming to an area and a time where it's just getting to be more common ground. So I'm a mind-body expert, but I've really been focusing on the skin for the last decade, and I'm a neuroscientist. So when I first started my work in the skincare industry, I was asked by both sides, like, wait a minute, what is a neuroscientist doing in skin and beauty? And on that side, why do we need a brain researcher to work and sell skincare products? So I made a lecture, and this is a lot of that part of that lecture, and this is what they were referring to on TED as well. I've given this as a TED Talk. And it really paints the picture of why this is important and why we should be talking about this connection between brain and skin. So on this lecture, I'm going to just give you an overview of this as briefly as possible. I think I've got 20 minutes with you. And so we're going to talk about the structure. Why is the brain so similar to skin, and why does that matter? And then we'll get into a bit of the emotional side of things, like why psychologically we're talking more mind-body than just brain-skin. So hopefully by the end, then you'll maybe start to think about different things when you have maybe some tingles and chills on your skin, and you can understand exactly what's going on in your mind as that happens. So to begin, I'm just going to talk a little bit about just some stories. I'm just going to move this out of the way. So, and if you can relate, feel free to pipe in, because these are actual people. So these are real people stories. I got them from medical cases, and in particular a couple doctors out in Massachusetts that were looking at patients that have really interesting and complex skin conditions. So on the left here you have Sophie, and Sophie is in high school. She's 18 years old, and she's a ballerina. So she's a senior in high school. She wants to know what she's going to do for the rest of her life. So in her mind, there's a lot of conflict. What am I going to do? Am I going to go to college? Am I going to continue to try to be a ballerina? Am I just going to do something completely different? So obviously, it's a little bit of a stressful time in her life. She develops a wart on the bottom of her foot. So on the sole of her foot, she gets this wart. What do you do when you get a wart or some skin issue? Drugstore, you go and you get some cream, and it doesn't work. So she goes, of course, if you have a skin problem, what kind of doctor do you go see? A dermatologist, a skin doctor. Goes to a dermatologist, they give her some cream, and yes, it goes away, but it keeps coming back. So she's got this now chronic, weird wart condition on her skin, on the bottom of her foot, and it actually made the decision for her, because she wasn't able to dance. So she couldn't continue to be a ballerina. But that wasn't her solution. She didn't want this piece of skin to tell her how to live the rest of her life. We will revisit her and how she ultimately got rid of the wart later in the lecture. And in the middle is Jack, and Jack is a pilot. Jack is a very experienced pilot, and he's used to flying all over the US. One day, he felt quite sick, and he couldn't do his normal rounds. So he asked his friend. And his friend said, sure, I'll do your route for you. And in a very tragic series of events, the friend, who was also a pilot, died in a plane crash going over a particular canyon. So Jack thought, well, obviously he went through some of this mourning with his friend. He felt rather guilty. But he didn't really think much of it after that. He was, a pilot. He had to just get on with his life. But every time he did that same route, his skin would break out in rashes. And he didn't know why. And he just had to live with it. So again, goes to the dermatologist. The dermatologist says, that's a rash. Here's a cream. Go away. And the rash only came back. And every time he went over that canyon. So again, something is going on in the skin that doesn't necessarily have to do with getting it treated by a dermatologist and a skin cream. And the last one is little Joey, and Joey was born with eczema. as a lot of babies are these days, and he suffered a tragic loss of his life. So he lost his mother. And after he lost his mother, his medications that were keeping his skin sort of healed and at bay stopped working. The medicine stopped working. So in all of these cases, there is something going on deeper than the skin. It goes beyond skin deep, that is affecting the skin, but it's not to do with exactly just the surface level. So we will revisit them a bit later. And one final example is something called a wedding ring rash. Has anyone heard of this? Or can think of someone maybe that has had this? So this is a particular rash that shows up on the skin under the wedding ring. So you can switch the wedding ring to the other hand and the rash will follow. And the only way that this rash goes away is when the relationship gets cut away. So you can tell now that your skin is telling you things that maybe you need to pay attention to, that are deeper than just an itch or a hive or some scratching. It's not so skin deep, it's much deeper than that. So that's what we're going to explore in this lecture, is this connection between the brain and skin and how it works, because we see this on a day-to-day basis. And to just kind of calm all the questions of these both sides that I was getting, I said, look, there's differences, of course, between brain and skin, but there's a lot of similarities. And so these similarities come about because the skin and the brain were one and the same when we were embryos. So early on, a long time ago, you were an embryo, and your brain and your skin were the same tissue. It's called the ectoderm. And you can see it here, that the ectoderm gives rise to skin cells, gives rise to the neurons of your brain, and also to melanin in your skin. So that color you have on your skin, on your hair, and in your eyes, and some in your brain, is due to melanin. The thing that is, let's say it's the precursor to melanin, is called L-DOPA, which is also a precursor to something we call dopamine. So there's a connection between something that affects our dopamine neurons in the brain, like, say, Parkinson's disease, and how much melanin you have. There's also a relationship between albinism, when you don't have pigment in your body, and deafness. So why are there these connections between having a higher risk of deafness if you're an albino? So we're just beginning to uncover these connections, because they really are showing us that everything obviously is connected, and we need to pay attention to our largest organ, our skin, to understand what's going on in our nervous system. This is just another picture of the skin, and in blue you can see the nerve endings. So you're just talking about the very, very superficial skin. So we're not even talking about the deeper layers of skin. And there's a lot of connections. So the structure of skin and brain originated in the same place. They are very interconnected. And as an example of something that you may or may not have seen is, at least in the skincare industry, we talk about sensitivity. So how many of you would say you have sensitive skin? That's about half, which is actually pretty true of the whole global population. 50% of people would say, yeah, I have sensitive skin. Now, you might think of it as it's red or it's flaky or just I can't do anything to it, but that's not what true sensitivity is. True sensitivity, again, is nervous system, not cutaneous or skin. So in this experiment, we have A and B. So in the A, the person said they were not sensitive to things. So they were, kind of normal skin. And then on the B is the people that raised their hands and said, yes, my skin is sensitive. When I put something on it, it burns or it tingles or I start to feel a bit itchy. And they threw them in an MRI to see if this was true or if it was all in their head. And what they found is that you can see in the red, here especially, you have a higher activation of this particular area, which is your somatosensory cortex, which is the part of the brain that maps out your senses of your body. So it's much more activated in the people that say that they were sensitive to the people that say they weren't sensitive when they were exposed to something called lactic acid. So what they did is they added a little lactic acid on the nasolabial fold, and they put them in the MRI machine, and they looked at their brain. So the people didn't even have to say that wow, this burns and tingles. You can see it in someone's brain. So this goes to show that the connection between brain and skin is unilateral. It's not just going top-down processing. The skin can also send communication and signals back up to the brain, and this is what it's very important now, because we know that the brain, tells the body what to do, but if the body tells the brain what to do, then we can manipulate that, and we can potentially find future cures for disease, disorders through the body, in particular the easiest one, through the skin. And just as a recap of this, how many of you have felt stress before? Everybody. Okay. Everybody. Especially if you live in LA and you have to sit through traffic and your body kind of activates. And so what happens is your brain obviously sends signals to your adrenals, which then send signals to all of your organs, including your largest organ, the skin. And the skin, all by itself, has all the machinery needed to process something like psychological stress. So the stress signals coming from your brain and your adrenals are processed in the skin. But the interesting thing is that the skin can do that all by itself. So your skin can feel stressed, even if you feel chill and normal and fine. And it's theorized that the stress response, called the HPA axis in the skin, in the brain, that this stress response first originated in the skin, and then our brain, as we evolved on this world and had to think of things like, that thing is going to eat me, so I should have some sort of evolutionary response to this, then the brain adapted the system from the skin. So it's a very deeply rooted stress system, deeply rooted in the skin, and the skin has everything that it needs to handle stress. It makes its own cortisol. It makes its own testosterone. It makes its own estrogen. Even if you didn't have ovaries, it would still produce estrogen. So a lot of this, to me as a scientist, as a neuroscientist, is fascinating because we can potentially tap into the skin for extra melatonin or extra estrogen when somebody goes through menopause. So the implications are really, really far and wide here. So to get into this next part, so that was more like the structure of skin and brain and how everything is connected. But to get into this next part, now we're going to expand into more mind-body. So we talk about the psychological effects, how you feel about certain things. And before we get into that, I wanted to kind of like give you guys a little example of how it might be to have your senses cross over in something like a synesthesia. So I'm going to play two sounds, and this is probably the first or maybe only time you will be asked to take out your phone during a science lecture. So does everyone have a phone with a nice smooth screen on it? You don't need to get on your Twitter already, just, settle down. So what I just want you to do is run your finger on the screen and just feel how nice and smooth it is, if it's clean, of course. If not, just give it a little rub. So what we're going to do is we're going to hear two sounds, and I will go with this twice, so if you can't catch it the first time, you will. So what this experiment should show is that the sounds can also affect how your brain perceives touch. This is the sound of paper. Okay, just kind of think about that. And this other sound is the sound of sandpaper. So I'm going to go back and I'm going to put these again. So what you can do now is you can close your eyes so that you have less sensorial interactions, and just think of what it feels like as you hear these sounds. Okay, everyone ready? Great. We're going to hear these sounds now. And run your finger through the smartphone. Well, let's hope it works. Oh, of course. see if you notice a difference with this sound. Did anyone notice anything different between the two? It's kind of a tricky experiment. It's obviously we're not in a lab. But the thing that you're supposed to feel is that when you hear the louder sound of sandpaper, say, your fingertip then sends the same signals to your brain, but then your brain recalibrates and says, wait a minute, this sounds like it should be rougher, and so you should feel a little bit rougher on your own skin. So that is the connection between sound and touch, which is very real. If you think about the brain, your temporal lobe is here, you got your sound coming in this way, and also your touch receptors that end up here from your fingers, as you guys just saw in the previous presentation, should show that there are connections and like cross-modal interactions in the brain, and even synesthesia. And there's a really fascinating story about a woman that was feeling sound like a massage, and it's because she had a stroke. And after the stroke, every time she heard low bass sounds, she physically felt them as these waves of a massage. Is there a future in this? I think there is. You know, there's something to the sound baths that people have been doing for maybe hundreds of years, and maybe we'll be able to tap into this for real medical purposes. If you are deaf or hard of hearing, there is some research showing that if you vibrate the skin on your fingertips, like if you wear a special glove, you will hear better. So again, we're looking at the skin as this frontier in expanding our neuroscientific understanding of our bodies and also just our mind-body interactions. So coming back to this, in the late 30s, there was one publication about how cats have this very special fiber called a C-tactile fiber. And for many decades, most scientists didn't think that humans possessed it. And they looked at cats because when you pet a cat, anyone try to pet a cat the wrong way on their fur, they probably run away, right? Or any animal. So if you think about our language, somebody that says, ooh, they rubbed me the wrong way, there's some truth to that. That means that we like, as human animals, to be rubbed in a very specific way. And what is this specific thing? These are called C-tactile fibers. They respond to human temperature in the human skin and found only in hairy skin. So you don't have them on the palms of your hands or the soles of your feet. So they respond at 3 centimeters per second. You can't just go up to somebody's arm and rub it really slow because what does that feel like? Pretty awkward, right? You probably are like, stop that. If you do it too fast, people don't like that either. 3 centimeters per second and 98.6 degrees Fahrenheit. If you do this, too cold, too hot, it's highly specific. The other fascinating thing about it is that if you compare a regular nerve fiber found in the skin, think of a Ferrari, it's going up to 200 miles per hour. These little fibers, slow nerve fibers, C-tactile fibers, they go maybe 2 miles an hour. So it's a comparison of taking a little bit of a leisurely stroll, walking, versus a Ferrari zooming by. Not only do they transmit their information at such different speeds, they also transmit their information to completely different parts of the brain. So in the brain, you have a part called the somatosensory cortex, which you saw in the MRI scale image. And so when this somatosensory cortex tells you what you touched. You touched something cold. You touched something hot. It was in the back of your arm. It was on the forehead. So it discriminates between temperatures and places, and that is what you've touched. The C-tactile fiber goes to the insular cortex. The insular cortex processes emotions, among other things. So it tells you how you feel when you've been touched. An example is, has anyone had a fight with a significant other, and that significant other tries to make things better by touching you? Why? Your brain, actually your prefrontal cortex, has overridden this mechanism. So normally this feels great. and you want your partner to caress you. But when you're in the middle of a fight and they do this, you're like, this doesn't make sense, does not compute. Why? Because your prefrontal cortex didn't want it to, because you're still in the fight mode. So, very complicated, very interesting, and again, it's only been in the last maybe 10, 20 years that we've rediscovered this fiber in the skin, and we're now beginning to understand the process of touch. And why is this important? So obviously, touch is the first sense to develop in the womb. So there's another one there. Yes, this is 2 womb mates. So touch is the very, very first sense to develop before sight, before hearing, before smell, before anything else. It's touch. It's integral to our survival as a species. If we don't get touched, we don't survive very well. And many, many studies have shown this. So taking this information, can we potentially treat more of these mental issues? For instance, a psychological disorder or some other form of brain-related disorder. Can we tap into something that's easier than opening up your brain and your skull? And look at the body and see how the body, through the skin, can potentially help. And there are some cases that show that, yes, we're just not looking in all the right places. We need to think of everything as more integrative, because it's a mind-body connection. It's not your piece of skin here, your eyeball here, your heart here. It's all connected. This is somebody, suffering from anorexia nervosa. So we know that this is a psychological problem, but there are some studies that show that when you compress the body with something tight-fitting like a scuba suit, a surfing, like a wetsuit material that's quite tight. So when they wear something that's a bit tight and has some compression, it alleviates the symptoms of anorexia, making them feel their body more, so they can understand that, yes, there's some body dysmorphia happening, and they can really help the body tell the brain, this is what the body actually looks like and feels like, and helps with the treatment. That's huge. Another example is with autism spectrum disorders. So autism obviously is very complicated, and there's a lot of different things from your environment to your genetics. And one other thing is how autistic people that have the more severe traits don't enjoy this tactile interaction. They don't enjoy the gentle touch. So if you do the 3 centimeters per second, which most people love, somebody with more severe symptoms of autism spectrum disorder, they don't love it. They actually disengage from it. They don't like it. So there's also something there, and there's a potential to maybe potentially treat some autistic conditions by looking at the body and seeing how we can rewire that pattern. So just to finalize this and takeaways of this, the skin and brain, they are connected. They're not so totally drastically different, even though I'm still on stages talking about this, because it's not something that you see every day, that they have the same origins, that we need to think about the brain differently by looking at our outer organs, and vice versa. The communication goes both ways. And again, I believe there's an untapped neuroplasticity in the skin. Just a couple days ago, they showed, there's a study that looked at how using creams, which is great for the skincare industry, but using specific creams as we age can help reduce the levels of inflammation, systemic inflammation, that lead to things like Alzheimer's and Parkinson's even. So now that you kind of have an idea of the shared origins and the fact that there's the same components in skin and brain, you can maybe start to think about the fact that, yes, maybe we can potentially treat things like, dementia and Alzheimer's by specific creams that are reducing the levels of inflammation. This article came out just a few days ago, just last week. So again, a lot more research will be going into this area. And we want to talk about how these guys ended up, right? Anybody curious or think that they got rid of their skin rashes and warts? Yeah, so they did. But they didn't do it by going to the dermatologist and getting a cream. I don't discourage you from doing that. I'm just saying that sometimes things are a little deeper. So what happened with Sophie? She actually went through a series of hypnotherapy and found that it was her anxiety that was causing the bodily reactions. And so when she was comfortable with her own decision to continue to dance, that wart never came back. Just like that. She didn't have to take any more creams for it. With Jack the pilot, he did some phone counseling with psychologists and also found that it was, again, his stress and anxiety that he had kind of bottled up that was coming out as these breakouts on his forehead every time he flew over that. He knew there was a connection, but he didn't know how to get rid of it. And so going and doing these psychotherapy sessions allowed him to talk things through and resolve them from the mind point of view, and then the skin cleared and never needed to cream again. And of course, with the little Joey, he went cognitive behavior therapies to, again, disengage from the trauma. And this was a little more difficult because, one, it's very traumatic for him and his age. And after all this behavioral therapy, he never needed a cream again. So these are examples, again, real-world examples. And like I mentioned, the wedding ring rash, these rashes only go away when the relationship goes away. So you can put as much creams as you want, but if you keep telling yourself that everything is okay and your body tells you it's not, it's sometimes time to stop and think that maybe your body knows something you don't. So it's always good to listen to your body and listen to your skin. And to end, just another quick animation example of how all of this is connected. I work also with the TED Ed team, and so we have this little animation just to show you again how your brain affects your skin and what you can do about it.
She's only a few feet away. The closer he gets, the more nervous he becomes, the budding zit on his nose growing bigger and bigger until it practically eclipses his face. She looks at him hovering nearby, sees the massive zit and giggles. He slumps away, feeling sick. Stress can sure make a mess, and it happens to both teens and adults. But how does it happen? Let's rewind to before the zit, to before Justin even sees his crush. Already late for school, Justin got to class just in time to hear the teacher say, "Pop quiz!" He hadn't done his homework the night before and felt more unprepared than the ambushed World War II soldiers he was supposed to write about. A sudden rush of panic swept over his body, leaving him with sweaty palms, a foggy mind, and a racing heart. He stumbled out of class in a daze and ran straight into his all-time crush, spiking up his stress. Stress is the general biological response to a potential danger. In primitive caveman terms, stress can make you fight for your life or run for your life if, for example, you're confronted by a hungry saber-toothed tiger. Special chemicals called stress hormones run through your body, giving you more oxygen and power to run away from danger or to face it and fight for your life. Hence the term fight or flight. But when you don't fight or take flight, you face the plight. When we're taking final exams, sitting in traffic, or pondering pollution, we internalize stress. It all begins in the brain. The hypothalamus, the master controller of your hormones, releases something called corticotropin-releasing hormone. This triggers the pituitary gland, a pea-sized gland found at the base of the brain, to release adrenocorticotropic hormone, which then stimulates the adrenal gland sitting atop the kidneys to release cortisol, the major stress hormone. These natural chemicals are a great help when you need to run away quickly or do superhuman feats of courage. But when you're simply sitting, these stress hormones collect in the body and affect your overall health. Stress hormones increase inflammation in the body, suppress the immune system, which makes you more susceptible to infection by acne-causing bacteria, and can even increase oil production in the skin. And this is the perfect storm for forming a pimple. Cortisol is a major stress hormone involved in making skin cells churn out oily lipids from special glands called sebaceous glands. But when there's too much of these oily lipids, called sebum, they can plug up the swollen, inflamed pores and trap the pesky acne-causing bacteria inside, where they set up house and thrive. Add a dash of inflammatory neuropeptides released by the nervous system when you're, well, nervous, and angry zits follow. To make matters worse, Justin is a boy, meaning he's got more testosterone than girls. Testosterone is another hormone that increases oil production in the skin. So his already oily skin, together with a boost in oil and inflammation from stress, is the perfect environment for bacteria to swell up into a major zit. So what could have Justin done to avoid the big pimple? Stressful situations aren't avoidable, but we can try to change our responses so that we're not so stressed in the end. And had he been confident in approaching her, she might not have noticed the pimple. Or he might not have had one.
Thank you. So I hope I've presented a little connection between brain, skin, mind, body, and again, a reminder to listen to your body. Thank you.